For question 26 in the practice exam, we're told that we make a 1 liter buffer by mixing together 375 milliliters of hydrogen cyanide, which would be our acid, with 625 milliliters of potassium cyanide, which would be the conjugate base of our acid. So we've got a buffer, weak acid, conjugate base. And they tell us the Ka of hydrogen cyanide is 6.2 times 10 to the minus 10. What's the pH of this buffer? So to find pH, pH is tied to the concentration of our acid and our base. And we have to find that new concentration because we're mixing these volumes together. All right, we take 375 milliliters of our acid and mix it with 625 milliliters of the conjugate base. So when we mix these two solutions together, we end up with a new solution that's 1,000 milliliters. So anytime we do a dilution, we need M1V1 equals M2V2. My initial concentration times my initial volume equals my new concentration at my new larger volume. So we need to do this calculation twice, once for hydrogen cyanide and once for potassium cyanide. So for the hydrogen cyanide, it's 0.5 molar, and I have 375 milliliters of that. My new concentration at 1,000 milliliters. Same calculation for potassium cyanide, except for we have 625 milliliters of that sample, and then we dilute that to 1,000 milliliters. So for our hydrogen cyanide and for our potassium cyanide, we can find our new concentration. Got 0.1875 molar here, and I've got 0.3125 molar here. Now to find the pH, right, we have our concentration of our acid and its conjugate base. Now to find the pH, we need the Henderson-Hasselbalch equation. pH equals pKa plus the log of our base over our acid. So the pH of this solution, so pKa is simply the negative log of my Ka. So my Ka is 6.2 e to the minus 10 plus the log of my base is the potassium cyanide. That's the conjugate base of hydrogen cyanide. So 0.3125 over the concentration of my acid, 0.1875. So pH equals 9.207 plus the log of 0.315 divided by 0.1875, which is 0.2218. I get a final pH of this solution of approximately 9.43. I would go two significant figures, right? 2 decimal places for 2 significant figures, because when we look at our concentrations, I've got 2 significant figures there, 2 significant figures there. Remember, in pH, the first number or any number to the left of a decimal place does not count towards significant figures. Only the numbers after the decimal place count towards significant figures. So I've got 2 sig figs in my concentration. I should have 2 decimal places in the pH that I report.